previously what we looked at was how to create the structure for a linked list so that a user could create the linked list with a constructor and could add an element to the beginning of it with add first. Now what we want to do is, and that required 3 classes. It required a linked list class, a private inner class called node, and then a third class, which was a class that the user wanted to store data with. So that could be anything that descends from an object, which is all classes. It could be a string, capital D double, something that the user has created custom, whatever they want to store in their list. We could handle that. That was 3 classes. Now what we want to do is we want to create the ability for someone who's using our linked list to walk through it with an iterator, meaning to be able to go through it as if they had a for loop, looking at each element of the list in turn so that they can process it. What kind of process might they want to do? They might want to find a particular element. They might want to maybe sum all the elements in the list. They might want to remove an element. There's a lot of things that you might want to do with a list of data, but we can't provide that functionality to the user unless we give them a way to walk down the list. So that way to walk down the list is called the iterator class. And that's now what we're going to create. You can think of this a little bit like if you remember those little spiders from Minority Report, or if you saw the Matrix, those sort of kind of mechanical octopus things that were attacking the ships in the Matrix. It's kind of what we're doing. We're creating this class that's going to keep these references to our list, and we're going to walk down it as we call our different methods. So we're going to create a simplified ListIterator interface, meaning an abstract class that says any class that is of type ListIterator must implement the next method, the hasNext method, the remove method, the add method, and the set method. So next and hasNext will enable it to walk down the list. Remove will enable a list element to be removed. Add will enable one to be added. And set will enable us to swap out the data at a particular point. Okay, our linked list had a private inner class called node. We're now going to give it a new private inner class. And be careful about the names here, because our new private inner class is going to be called LinkedListIterator. It's going to implement our ListIterator interface, meaning that LinkedListIterator will have next, hasNext, remove, add, and set, but the user will not be aware of the LinkedListIterator class. It will only be aware of the ListIterator interface. Okay? So our linked list will have a private inner class called LinkedListIterator. Because it is an inner class, it's going to have access to the node classes, and it's going to have access to that first variable. Things that are encapsulated and hidden from the user of our linked list, but which our linked list iterator must know about in order to walk down the list. So in this way, we're creating the architecture of a class that has this functionality for a user, but the user doesn't need to know all the details for how it's done. Our list iterator object, that walker that's going to walk down the chain, is going to have a couple references. The primary reference is one called position, and that's going to be a pointer that points to the current element that the list iterator is focused on. It's going to have a second pointer to the one that came before it, called previous, and that's going to be important so that we can add and remove elements to our linked list. We're going to have to do some special cases though, because if a linked list doesn't have any elements, or if it has one element, then you can't have an iterator that doesn't have one or more of those references be null. So we have to have some special cases. The last thing that we're going to keep track of within our iterator class is a flag called isAfterNext. This is a little bit of a housekeeping variable that helps us to make sure that we only remove one element at a time from our list. Move right. Okay, here is the definition of our linked list iterator class. I see that my mouse is in the middle of the screen, so I'm going to step up and move that for a second. There we go. Sorry about that. Here's the definition of our linked list iterator class. You can see that we have that same outer class linked list, and those 3 dots mean that we have other code there as well. But what we're adding now is 2 methods. Well, sorry, 1 method. 1 method which is called ListIterator, and all that's going to do is create a brand new linked list iterator and return it to the user so that the user can walk down the list. When we create that new list iterator, we're going to create it of type linked list iterator. That is going to be a private class that, like node, exists within our linked list class and so is only visible within our linked list class. What kinds of things does our linked list iterator need? Like I said, it needs a reference to its current position. That's a reference to a node. It needs a reference to its previous position. That's also a reference to a node. It has a housekeeping variable called isAfterNext, and it has a constructor that initializes all those variables at the very beginning. And what are we going to initialize them to? Well, everything's going to be null, and isAfterNext is going to be false. So that's the position we start at. A linked list iterator gets returned to the user where those private instance variables position and previous are both null. Move right. All right. So once a user has that linked list iterator by calling ListIterator and getting it back from our linked list, the user now is able to call the next method. That's part of our ListIterator interface. And so we want that to have the behavior of moving down our list. How does the next method work? Well, notice first of all that this method is within the linked list iterator class. So it is within the linked list iterator class, which is itself within the linked list class. Okay, when the user asks for our iterator to proceed to the next element, we first need to check whether or not it has a next element. That's a method that we have written here, presuming that it exists, but not describing how it works yet. We'll describe how it works in a moment. But our first check is if it doesn't have a next element, then we throw this no such element exception and we say, hey, there's nothing left. There's nowhere to go. Let's say that there is another element then, though. In that case, we're going to say that whatever our iterator currently points to as its position and whatever it currently points to as its previous is going to be updated. We're going to say previous now moves to position, and we're going to say position, if it's equal to null, then we're going to get the first node from our linked list parent, and it's going to point to the first element. So in that case, previous will be null and position will be first. But if it's not the first element, then we move previous to position, and we move position to whatever position.next was pointing to. So we moved our iterator forward. Now you have to be careful that you do these things in the right order so that you don't lose track of an object before you've set up your references. Move right. Okay, so we also have to be careful of what happens if we get to the end of our linked list. And if we get to the end of our linked list, well, we can have a couple situations. If the iterator is at the end of the list, which is empty, then first, the variable in our outer linked list class will be equal to null. Or, if there's no more elements after the current position, then position.next will equal null in our iterator. So that gives us enough information to be able to implement the hasNext method. Notice, the hasNext method is within our linked list iterator class, which is itself within the linked list class. So when the user calls the method, or when we call the method hasNext, the way we understand whether an iterator has a next element or not is first we check whether or not it's currently pointing to null. If it's currently pointing to null, then it doesn't have a next. It has a next only if the linked list first does not equal to null. Meaning if the linked list has something that it points to and our iterator has never gone there yet, then the next element is going to be the first element. But if our position is not equal to null, meaning the iterator is pointing at something in our chain, then the way we know whether there's something left in our chain is whether position.next is equal to null. And if it's equal to null, it doesn't have a next. So if it's not equal to null, it does have a next. And so we can return those two conditions based on what we see. Move right. That gives us the ability for a user to ask for a list iterator, to ask whether or not it has a next, and if it does have a next, to move across it and to return the element that it crosses over. Now, what we would like to do is we'd like to say, given that an iterator is currently pointing at a position in our list, I would like to remove that element. How do I remove that element? We do that by updating our references carefully. So first of all, the user who is walking down the list finds something that they want to remove by looking at the element. And so then they can call remove. This is what they're calling on their iterator. Our implementation will know whether or not we're going to call remove first or do a more general update along the way. All right, so what we're going to do is if the user asks our iterator to remove the element it's pointing to, we're first going to check to see if it already has removed an element. That's what we're checking for the is after next. If is after next is false, then we're going to break because we can't remove something unless we've moved over something previously. Because we've moved over something previously, we know position is not equal to null. All right, so here's the first thing we do. We check to see whether the iterator, what it's pointing at, is the same as what the linked list is pointing at for the first element. And if it is, then we call our linked list method remove first, which we've already done. And it'll patch things up and everything will be fine. If we're not pointing at the first element, then we have a position element and we have a previous element. And the way that we're going to remove this element here is we're going to go back in our chain. We're going to take previous.next, which was pointing at position, and we're going to say previous.next points to position.next, bypassing the element that we want to remove. Finally, once we've removed our element, either the first element or the one that we wanted to bypass, we say that our iterator's position, which was pointing at the one thing that we want to remove, is now backed up one to the previous element in the chain. And this is when we set is after next to false, because we don't have a clean setup of our iterator at this point to remove something again if the user calls remove element twice. Move right. Visually, this is what's happening. We start with a linked list that has a first element that points to the first element in a chain of nodes. Our nodes contain data. For example, Diana, Harry, and what's our last one there? Romeo. Our iterator's position currently points to Harry, and the previous one points to the node containing Diana. So the user who has the list iterator says, I would like to remove the current element that the list iterator is pointing at, the one that contains Harry. So the first thing that we're going to do is we're going to take the previous element, and we're going to say the previous.next equals position.next, bypassing our element that we want to remove. Then what we're going to do is we're going to say position equals previous, so that our iterator is set up on the valid chain, not on the element that we just removed. And finally, we're going to say is after next equals false, so that we don't try and remove an element where we don't have a previous and a position pointer set up well. Move right. So that's what we want to do if we want to remove an element from our chain. What if we have an iterator and we would like to add something to our chain? Well, we can do that. What we need to do is we need to just make sure that we keep all our connections appropriately set up. We need to make sure that we set the is after next flag to false, because when we're done with this, our iterator is not going to be set up well to remove something. But what we're going to do is we're going to implement the add method. The add method is within the linked list iterator class, which is within the linked list class. The add method is something that the user has access to because it's part of the list iterator interface. The user would like to add something to our list. And so you can see that in the signature for the add method, there's no mention of a node class. All we have is add and the object element that they want to add to our chain at the position relative to the list iterator that they've currently got. All the other instance variables are set up with some state that reference where in the chain we are. Okay, so what do? We have a list iterator. Let's consider the case where we're at the beginning of a list. In that case, position equals null. And if position equals null, then we call our linked list parent class and say, hey, you're an empty list, so just add something to the beginning. So we'll call that method add first, and we'll pass in the parameter that the user wants to add. Great, everything's taken care of. We'll just clean up our iterator so that position equals the first element of the list. Let's say that our iterator is in the middle of the list, and so we have position and previous set to something. Well, in this case, we need to do the work of inserting something into our chain. Well, what is our chain made of? It's made of node objects. So we're going to create a new node object by calling the constructor to create something to splice into this chain. We'll call that constructor. We'll say the data that node is storing is element. That's what our user wants to pass in. And where we're going to put it is we're going to put it at the position. We're going to say the next node is going to be whatever our iterator was pointing out in position. The position was pointing here. We're going to say, oh, this node's next element is going to point to the same thing. So position.next, new node.next will equal position.next. And then we'll say position.next equals new node. So we'll splice in a new element to our chain. And finally, we'll update our list iterator so that our position is equal to the new node that we just added. Because we haven't moved down our list by calling the next method, we're going to say is after next equals false, and that'll prevent us from calling a remove or a set method out of turn. Move right. Here's visually what's happening. In this case, you can see we have a linked list, we have 3 node elements, we have our list iterator, which has a position, and what we want to do is we want to insert this new node into place. And so you can see that what we do is we create that node, we store the data that the user wants stored in the list, we say node.next equals position.next, so we splice in the new node, and then we say position.next equals new node. That splices into the chain our new node. Finally, we clean up our iterator by saying that our list iterator.position equals new node as well. Move right. The last thing that we have to enable our list iterator to do is to change out the data that's stored at the current element. And this really is one of the easiest things to do. Because what it means is that the user calls set to our iterator and just swaps out the data. So they want to replace what's currently pointed out by position with the data that's being passed in by element. So first, we just make sure that our iterator is in a good state by making sure that is after next is true. If it's false, we throw an error. And then if everything's okay, we say position.data equals the new element that the user wants to store. And the old element is just lost track of. And that's all there is to it. Okay, so that gives us enough capacity to be able to create a linked list with a linked list, a node class, and the class that the user wants to store. It also gives us a linked list iterator that enables us to walk down this list. So we can now present to the user a fully formed linked list implementation that they can call all those list operators on that we need them to be able to call on. All right, thank you. That's enough for this lecture.